guys, welcome back to your channel Kido Algo. I am Daud and we are continuing a series where I am explaining how to use Google Earth Engine and its lot of functionality and so many things in details. So without further ado, let's jump straight into the video. So today in this video, I will show you how you can import an image collection from the datasets in Google Earth Engine Cloud Storage and filter the images using filterDate function and then add different layers on them. So you guys are ready? Now first I will start by writing some code in our Google Earth Engine code editor. So as we are using the language JavaScript to write the code. Now I will write a print function first and write hello world. Now simply if I run the script, you can see in the console we can see the hello world is showing. We can also format this text in the JSON format. So now we will see that how we can find our required image from the datasets. I will put the link of the page where you can find all the datasets stored by the Google Earth Engine in the cloud. As you can see, the Landsat images, Sentinel images, Moses images. Now we back to our script. We can search all the data sets from here the search place, but by just typing the name of the dataset you require. Suppose I am writing here the Landsat 8. Yeah, you can see for the Landsat 8 collection, we are seeing there are various types of collection it has in the cloud storage. So we will just simply take one of the collection. Here you can see here is a code snippet. You can also copy this code snippet and paste in your code editor. You can see here various bands that are given for the image. You can see here is the total 12 bands for the Landsat 8 image, and also it's given various properties for that image. Okay. Also I will put a link about the bands of the Landsat images where you can find more about them. Now just by clicking the import button, we will simply import this image collection in our code editor. As you can see, the collection images successfully imported in our code editor. Now you know we have a giant collection of images in the Landsat 8 raw images dataset from back in 2013 to present. So let's see how many images it contains in total, right? So I'll just simply remove the hello world. If I take the image collection and apply the size property, it will show how many images it contains. Now it's computing the total number of images that it has. It actually has a lot of images. That's right. Yeah, it's now showing. So you can see it's around something 12 lakhs of images this collection has, right? So we don't require as that much of images. We just only required one image for our properties. Right? So how we can get the only one image, that means how we can sort them according to our requirement. We can use the filterDate function to sort the images. So if I apply simply filterDate, and in the docs tab if I write filter date, yeah, it's here for the image collection. Here you can see it's required two arguments. One is start and one is end. We have to mention the two argument, that is for the starting year of the images that it has for to the ending year, right? So as the Landsat 8 has the images from back in 2013, now if I want to take the images from 2040, we need to pass the year, month and date as a value. So as you can see in the documentation, we need to require the start date and the ending date. So if I just put the dates here, suppose first the year, then followed by the dash, the month, that is 01, okay, followed by the 1 dash 0 1, then again 1 dash 01, that is 2014 year, the month January, the date is 1, and now we are giving the ending date, that is the same year 2014 followed by the second month February and the same date 01. Now if I run the script, yeah, you can see now a error has popped up in the console, right? It says the collection query aborted after accumulating over 5,000 elements. So what does it mean? That means it's saying that the collection can be printed directly to the console, but the console printout is limited to 5,000 elements, right? So collection larger than 5,000 images will need to be filtered before printing. So between these two dates, it has the elements, that means images over 5,000. So that's why it's unable to print the elements. Printing a large collection will be correspondingly slower, so that's why it's unable to print. So we have to more filter the data, right? So as you can see, still we just for 1 month gap, it has over 5,000 images. So just let's try to filter between 1 days. Then is it okay? So if I just run the script, sorry, I give the same date, okay, same month and the second day. Now run. Yeah, now you can see it's showing 287 elements. That's why the console is able to print out the element. By the way, if I want to know more about the Landsat data, I will put a link where you will find all info about Landsat 1 to 9, suppose like launching dates, sensor information, resolution, bands, launching base. Okay. So now you can see, now see it contains only 287 images. So just think, we have reduced the number of elements from 21 lakhs to 287 by only using just one function. We can also sort the images elements by using geometry tools. These geometry tools. Okay. So how you can sort them using geometry tools? We will discuss them about in future videos. So now we get an object of image collection with 287 elements. Now if I click in this object and click on the properties, and if I go straight to the bottom, you can see the most yeah, here you can see here the most popular band combinations are given, like true color, near infrared, short wave infrared, and also we will see some more band combination later in this video. To know more about band combinations of Landsat images, I will put a link in the description box where you will find all the band combination for the Landsat images. I will put a link for Sentinel data band combinations also. You can try with Sentinel data on your own. Now, if I open the features tab just by closing the properties and open the features tab, you can see the total 287 images are here from different places. Total 287 images. So now if I want to take just only one image and perform all operations, okay, I can copy the image ID. Here you can see this is the image ID. If I just expand this image element, you can see this is the image ID. I can simply copy the image ID and then create a variable called image and then paste the image ID with uh, just creating a variable called image and creating an image object. Here I have created an image object. Now if I just comment this out and simply print this variable image, let's say print image, and run the script, now you can see it's only showing one image that I have just copied. There is also another one method to take only the first image. I will show it also to you. Like say if I just again print the statement and if I apply a method called first, you will see it will also give the first element from the image collection. See, the same ID, the same image element it's given. Okay, and if I just simply copy this whole thing and paste in place of e.image the image object that I created using the copying the ID exceptionally, you can also do this by this method. Okay, but I just showed you that you can also take the first image using the first method. Again I am commenting this line and comment out this line. So here you can see there is another problem. We want to see that the from where the image has been taken. So we can apply an property called Map.center object, right? This is an property. I can simply show you this property from the documentation tab. Center object. See, here this center object is taking uh, three arguments. One is object, the image object. Second argument is zoom level from 0 to 24. And third argument is a callback which is triggered after the recentering completes successfully. Passing this parameter causes the center object operation to run asynchronously. You don't need to bother about the third argument. You have to only use the first two arguments. Okay. So if I just simply pass the image object and set a zoom level, suppose 9, and if I just run the script, see, here see, the map moves from its place and it's applying the zoom level 9. Okay, and it's showing the place from where the image has been taken. Now if I change the zoom level to, let's suppose, 5, and if I run the script, you will see, you can see the zoom level is changing in the map accordingly. Okay, if I change it to 2, again you will see it zoom out a very. So let's get back to the zoom level 5. It was right. Okay, now there's another thing. You might be thinking, like, the whole lot of time I'm saying the images, but you cannot see any images, right? Now to see the images captured by the satellite, you need to add the layer of the image. For what? I will write a command. There is another command. Please keep concentrate here. That is Map.addLayer, and I just simply pass the image object. So if I run the script, now see, this is the image that has been taken by the Landsat 8 satellite. Now just if I simply go to the docs tab and write add layer, it was there, yeah, right here. It's taking some arguments. First, the image object that I already passed. Second argument, it is very important, the visualization parameter. I will discuss it about in this video later. Okay. The third argument is the name of the layer. You can give a name for this layer. And the fourth argument is a flag indicating whether the layer should be on by default or not. And the last argument is the opacity. You can simply define the opacity of the layer of the image, right? Now let's define some visualization parameter for the image to make it more understandable, right? First, I need to know which kind of layer we need to add for this image. So there are various kind of images. So if I go to a site, here you can see, I will put the site link in the description box. It's giving me some band combinations for the images. I can simply put the bands as I shown before that Landsat 8 has 12 bands. These are the band combination that will produce the images of named like natural color, color infrared, shortwave infrared, agriculture, geology, etc. You can try this on your script also. Now let's create the visualization parameter. Now keep focus here, keep your attention here, how I am creating the visualization parameter. I will just simply define a parameter called vis params. Okay, and here simply I am creating an object. First I will define the bands and create an array of the bands. If I just choose the first band combination, that is the natural color, I will pass the bands like B4 for the fourth band, B3, and then B2, right? I also need to define the minimum digital value, let's say suppose 5000, and the maximum digital value, let's say suppose 15,000. We also need to give a gamma value, suppose I am giving 1.6, right? So if I just cut the Map.addLayer and paste it below of the visualization parameter and simply copy this and pass this as an argument here and run the script, see the layer has been appeared. This is the true color for this image for the band combination. Now let's say suppose if I take another band combination, let's say suppose for color infrared 543, on the same visualization parameter I will just change the band combination, and if I just run the script you will see a different layer has been appeared here. So you can try from all these sets, okay, at your home. Here is the thing, we can also define the visualization parameters using the layer manager. Here you can see this is the layer manager. First, if I click on the settings here, it's defining the 3 bands or the 1 band. If I click on the 1 band, it will simply show me the 1 band. Suppose this is the B1, and if I change it to the B2 and apply, and suppose let's say if I take B10, for different sets of bands it's showing me different images. I can also pass the name as a third argument for this layer. Suppose uh, as a third argument if I click, so true color, it was color infrared, right? Color infrared. Simplify, just run. If I click on this layer tab, you can see the name has been appeared for the color in for the layer. The when it is useful. So suppose if you have applied more than one images and you need to differentiate between the layers, you can simply give the names for the different layers, and you can check and uncheck these layers also by clicking this check button. Now if I simply go back to my layer manager, we can also change this minimum and maximum ranges from customly here. So if I just give like stage C, see the image has been staged a little bit, and stage mode, the image is changing with the changing in the range value, right? Also we can change the gamma value of this image. So if I just take it to the 2.84 and apply, you can see the image has been changed. Then you can think the what gamma value is defining. The gamma value is actually defining the brightness of this layer. If I just simply lower the gamma value and click apply, you can see the image become darker. And if I just increase the gamma value and apply, you can see the brightness has been increased, right? You can see more about the image visualization parameters. I will put the link in the description. You can check on that link. So if I take the gamma value simply back to somewhere middle and apply, now it's better for the visualization. You can also change the bands from here. So if I take another like for short wave infrared 764, so I change this band to the 7, it to the 6 and 4, and if I just apply, you can see the image also changed, right? Also here is the thing, you can import the custom visualization parameter in your script by just clicking on this import button. See, the custom image visualization parameter has been imported, that is band B7, B6, B4, gamma value 1.20, and max and mean value and the opacity, right? Here is the another thing, you can also change the opacity from here. I am keeping the opacity right now 1, and I am simply changing the bands also and apply. We can also change the opacity from here, as you can see. And there's another thing I can say, you can also set the, if I don't take here, like suppose comment out the center object, now we don't know the where the image map view will be landing, so we can simply use another method like Map.setCenter, and if I go to the inspector tab and click somewhere in the middle, you will see there is the parameter we are getting, the points. Here, if I just simply the parameters and paste it here and define a zoom level, suppose 5, and run, see it's taking me to that particular image. Let's suppose if I take somewhere else, here it's giving me the another point, the argument, and if I simply copy this and paste it here, and if I run this, I need to take somewhere else. Okay, and paste it here, and if I just run, see it's not taking back to me where the layer has been added. It's centering the map view where the map center is defining in this place. Okay, so that's why I will suggest you to use the Map.center.object. If you don't know where your map layer is in the map view, and if you know where is your map view will be generating the map view layer, you can use that Map.setCenter method. Otherwise, I will suggest you to use Map.centerObject. You saw the both function how it's working. Now it depends on you how you will use them, right? Now there are different bands are defined for different colors. You can see more about the bands in the link I have provided in the description box. Yeah, so that's it for today's guys. I'll be coming on the next video with some more remote sensing stuff. You can reach out to me in my Instagram and Facebook ID and ask your questions. And if you are enjoying our video, you can like, comment and share the videos for more reach, and also subscribe the channel. You can comment your doubts in the comment section, and you can say have you practiced these codes yourself or not. So until then, have peace.